All right, this lesson is going to be on inverse trig functions. Basically, we want to review inverse trig. It's something you would have done in geometry. Our main goal is to solve trigonometric equations, which is one of the trickier things we do and one of the harder things in the trig unit. Unfortunately, we can't do this lesson in class, so I'm stuck doing it on the computer. Hopefully you'll understand what's going on. So we'll get to trig equations, but the building block for that is being able to do inverse trig. So when we want to solve a trig equation, we need to get rid of the trig function. So if I were in class, I would have given you this as a warm-up. It's worth thinking about. So it asks you to name three angles that have a sine value of 1/2. If you really want to see if you could do it, it's on a video, you could pause it, see if you can come up with some angles. I'm just going to go ahead and name some. 1/2, hopefully, if you've memorized that table, which I think now we're getting a month and a half in that said, hey, memorize those table values at 30, 45, and 60. If you remember your table values, it probably wouldn't be too difficult to come up with an answer of 30 degrees, because basically it wants at least one angle that has a sine of 1/2, and the most obvious one is 30, because sine of 30 degrees gives you 1/2. Now, the issue is there are other ones. So 30 degrees is not the only angle that has a sine of 1/2. If you go up to 150 degrees, for example, in quadrant 2, a 150 degree angle also has a sine of 1/2. If you remember how to evaluate those, the reason 150 has a sine of 1/2 is it's basically its mirror image. If you took the reference angle for 150, you'd do 180 minus 150 and get 30, and you'd use the sine of 30, and you'd get the number 1/2. And since you're in quadrant 2, it would be positive. So not only does 30 answer this question, but so does 150. Now you have to be careful, because there are two other angles in quadrant 3 and quadrant 4 that have a mirror image of 30. An angle of 210 you might think works, but 210 would have a sine of negative 1/2, and 330 would have a sine of negative 1/2. So angles in quadrant 3 and quadrant 4 won't work to answer this. But so far we have two answers. Quadrant 1 answer of 30, sine of 30 is 1/2. Quadrant 2 answer of 150, sine of 150 is 1/2. Now, there are more angles because you can keep going around. If you go into quadrant 1 again after you swing around once, so say you go beyond 360, you hit 390. The sine of 390 is 1/2. And if you go even further, you can go back into quadrant 2. So there's actually infinite answers to this. You can keep wrapping around and around and around and getting answers in quadrant 1 and quadrant 2 that are higher and higher and higher. You can also go get negative answers to this as well. It's not just positive numbers that work. A negative angle that had a reference angle of 30 would also work. So, for example, negative 330 would work, as well as negative 210. And all these could be verified in a calculator. If you took a calculator, I mentioned any of the ones that I have told you, they would have sines of 1/2. So the weird thing about this is, even though the warm-up says three angles were what you're supposed to name, there's actually infinite angles, so long as they have a reference angle of 30. So this makes our goal a little more difficult. So the goal here is to be able to solve problems using inverse trig functions. Our major goal of this whole section is to solve trig equations. But for now, we're just going to evaluate inverse trig functions. Basically, inverse trig goes backwards. If, like in the warm-up, if you have a trig function, you normally put in an angle and you get out a number or a ratio. So you put in 30 degrees and you get out 1/2. Notice the warm-up asks the question backwards. It goes, if the trig function comes out as 1/2, what was the original angle that made that happen? The problem is that there's multiple answers, but we need a primary answer. So I'm going to show that there's many, many answers, but there's only one answer a calculator will give. It tries to give the primary answer. So on that warm-up, if we go back, when asked, name 3 angles have a sine of 1/2, the most obvious answer, if you know your trig, is 30 degrees. If you put it into a calculator will give you 30 degrees. The problem is it won't tell you the other ones. There are other answers. It just gives you the primary answer. All right, so let's look at evaluating some of these inverse trig functions. And then the subsequent videos after this will show how we use inverse trig to solve trigonometric equations. So the basic idea is to go backwards. The top equation shows a fact you should know, that sine of 30 degrees is 1/2. So the notation for inverse, which hopefully you've seen before in geometry, the main notation has a little -1 up there. That -1 just means sine inverse. So sine inverse goes backwards. Basically, if you plug in 30 into sine and get out 1/2, sine inverse should go backwards. You should put 1/2 here, and it goes back and gives you the angle. So in a trig function, the angle gives you a ratio. With inverse trig, you put in the ratio and it pumps back the angle. Now, I had mentioned the problem is that there are many answers to this. There are lots of angles that give a sine of 1/2 because of the cyclical nature of the unit circle. 30 is an answer, 150 is an answer, 390 is an answer, and then there are negative answers. There's -210, -330. I put the dots because the more you're willing to go around the circle, the more answers you get. Now, in a calculator, you'll notice the calculator is programmed to only give you the primary answer. So I'm putting the calculator in degree mode and see if you can see this. So there's the calculator. And I put in sine inverse of 1/2, a little blurry. There you go. Now, when I get to evaluate that, the calculator is not capable of pumping out infinite answers. It's just going to pump out the primary answer. So when you go to answer an inverse trig problem, you want to be able to get the primary answer, but you have to realize you may also need to come up with these other answers, which can be a little tricky. So we'll talk about how we come up with the primary answer that a calculator would come up with. And then later, we'll look at how to get other answers if necessary. So for whatever assignment or work that you'd have to do for this, realize when I go to get an answer, I just want the primary answer. So in this problem on the bottom, if they ask me what's sine inverse of 1/2, the proper answer is to give the answer 30 degrees and not list out all the other ones. Just realize the other ones also fit it, but the primary answer that we want is 30 degrees. So how do we get these primary answers? Well, there's an issue with the quadrants. So if I actually put sine inverse of -1/2, once again, there's lots of angles that have a sine of -1/2. So this is asking me, sine inverse of -1/2 goes, hey, can you tell me an angle that if I take the sine of it, I get -1/2? Once again, there's lots of answers. There's actually infinite answers. So some answers are 210, 330, 570. On the negative side, you could do -30, -150, and so on. Once again, the calculator, though, we want to be able to come up with the primary answer. So what the calculator gives, it's actually a little weird because you might think it would go for maybe that 210. But I'll show you the calculator because of the way mathematicians chose to do this. If you put in a negative ratio, it actually goes to the closest quadrant nearby. And once again, a little blurry. See, I don't know if the thing will clear it out, but I think you can see it well enough. Sine inverse of -1/2, it reports -30. It actually goes into quadrant 4 to get it, but it doesn't want to skip over. It doesn't want to go to 210 or 330. They basically want to just go backwards from 0. So they want this nice sort of smooth, continuous answer. So if you go into the positives, you go into quadrant 1, and then if you go negative, they just go backward into quadrant 4. But they go backwards by doing negative angles. So it's a little weird, but you can see the sine inverse of -1/2. Its primary answer is actually -30. So it's this part's a little confusing. Not the best thing to do as a first lesson on a computer, but obviously we can't be in class, so I'll do my best to explain this. This shows you basically if you have the inverse function. So this is inverse sine, inverse cosine, inverse tangent, where your answer will come from. So the good news is if you're taking inverse sine, inverse cosine, or inverse tangent of a positive number, a positive ratio, it always gives a quadrant 1 answer. So when I did sine inverse of a half, it was going to give me the quadrant 1 answer of 30. It wasn't going to give me any of the other ones. The part that's a little confusing is if you have to do sine inverse, cosine inverse, or tangent inverse of a negative number, it's going to generate the answer out of different quadrants. It goes to the nearest quadrant, but sometimes those answers are negative angles. It comes from the stack diagram. So basically, if your sine, if it's a sine inverse, I should say, if your sine inverse, your answer is going to be a positive angle off quadrant 1. If your sine inverse is of something negative, it means that your angle has to be somewhere under the x-axis to make a negative height. They decide to get the answer to come out of quadrant 4, and they use the negative angle in quadrant 4. So that's why it came up as negative 30 and not as 330 or 210, which are also angles that are on the bottom. But it goes to the nearest one, so it will do negative angles. Tangent does the exact same thing, because basically inverse tangent, if you do it of something positive, the angle will be positive. If you do inverse tangent of something negative, it'll pick out of quadrant 4 and give you a negative answer. Now, that's all fine and good. If you do get it, when I do some examples, hopefully you'll get the idea. Cosine is a little different because cosine can't be quadrant 1 and quadrant 4, because if you have a positive value for cosine inverse, so you do cosine inverse of something positive, it'll come out quadrant 1 like the others. But if you do cosine inverse of a negative number, the problem is that cosine isn't negative in quadrant 4. So if you say, hey, I want some angle that has a negative cosine, there are no angles in quadrant 4 that work because they'll all come out positive as well. So the closest quadrant that has negative cosine values is quadrant 2. And unfortunately, because it's drawing off quadrant 2, these will also be positive angles. So it's a little confusing. But like I said, I'll hopefully the examples will at least illustrate somewhat what I'm talking about. So keep this in mind if you're doing inverse sine, inverse cosine, or inverse tangent. Look at whether what you're taking is positive or negative. Anything positive will generate a quadrant 1 angle. Anything negative for these two will generate a negative angle in quadrant 4. Anything negative in cosine inverse will actually generate a positive angle over in quadrant 2. So let me show you a couple examples. So say I wanted to evaluate these. So I got 4 examples up here. I used table values. So these are ones I should be able to get without a calculator. I could put them in a calculator, but since we know our tables, supposedly, I hope you do, since I know my table, I actually know the answers to these. So the top 2 are a little easier because they're of positive things. So I'm going to do sine inverse of radical 2 over 2. If you know your table really well, what angle goes with radical 2 over 2? Well, the primary angle that goes with that is 45 degrees. So the answer to this one, what's sine inverse of radical 2 over 2? The answer to this is 45 degrees. Once again, there are other angles that work, other multiples of 45. However, the primary answer, the one that we'll give, is the one out of quadrant 1. So that's what was here. We're going to give a quadrant 1 answer. So for the first one, sine inverse of radical 2 over 2 is 45 degrees. Get this thing to work. There we go. Now, cosine inverse, I decided to use a half here. That's another one of our table values. If you know your table really well, cosine inverse of a half would come from 60 degrees, because basically cosine of 60 would give you a half. So once again, this was a positive number. You got to think backwards. What angle would give me this as a cosine? If you know your table well, it's 60 degrees. So once again, it came out of quadrant 1. Now, it's a little screwier with the negatives. So what is the answer to this one on the bottom? What's the sine inverse of negative radical 2 over 2? The answer is going to come out of quadrant 4. And it's not going to be a positive angle. They're not going to go with 315 would be the one that looks like 45. So the answer is not 315. They actually go with negative 45. So sine inverse of negative radical 2 over 2 is going to come out of quadrant 4, and it's going to be as the quickest angle you can get there. So instead of wrapping around and going to 315, they just back up and go to negative 45. So the answer to this one is the angle out of quadrant 4 that works, which is negative 45. Now, the problem with cosine is we're doing cosine inverse of a negative, and that answer can't come out of quadrant 4. The reason for that is because quadrant 4 doesn't have any negative cosine values. So this table, I'll go back again, keep going back and forth. Cosine, my answer is going to come out of quadrant 2. So the quadrant 2 angle that works is going to be based on this one. So the answer to this was 60. I need to think of what 60 looks like in quadrant 2. So I can do that by basically taking 180 minus 60 and realizing that it's 120 degrees that has the reference angle of 60, but since it's in the second quadrant, comes out negative. So the answer to this one is 120 degrees, because basically the cosine of 120 would be negative 1/2 as the first angle to have that property. There are lots of angles that have that property, but the first one you run into is a quadrant 2 angle, and it's 120 degrees. So it's a little confusing about this, maybe very confusing, depending on who you are, is just because this is negative doesn't make your answer negative. When it's sine inverse, this will come out as a negative angle. When it's cosine inverse, you need an angle that has a negative cosine, and it's actually coming out of quadrant 2, so these will come out with positive answers. So once again, to go through the answers, because it's a little hard to write on this because I don't have a smart board. This is my computer. So to go through the answers again, sine inverse of radical 2 over 2 is 45 degrees, using the table backwards. Cosine inverse of 1/2 is 60 degrees, using the table backwards. If your sine inverse a negative, you're coming out of quadrant 4. So instead of it being 45 degrees like it was up here, it's actually negative 45 degrees. And this one was 60 degrees. The answer to this isn't negative 60. It's 60, what 60 degrees would look like in quadrant 2, which is, you could do 180 minus 60 to get that, but it's a 120 degree angle. So the answers are 45, 60, negative 45, and 120, all in degrees. Here are a couple other ones. The top, you might go, arc cosine, what the heck happened? Why does it say that? Unfortunately, mathematicians never agreed on the notation, so you may or may not have seen this in geometry, but if you see arc just means inverse. Basically, mathematicians and scientists use this notation with the -1. Engineers and people who use applied trig tend to use this arc cosine. It means the same thing. So basically, arc cosine means cosine inverse. And you could also see arc sine or arc tan. So if you see an arc in front of it, it's just another way of writing the inverse. So I just decided to put that in there so we could talk about it. Arc cosine of negative radical 3 over 2. What would the answer to that be? This is asking for cosine inverse of this. If this were positive, cosine inverse of radical 3 over 2 positive from your table would be 30 degrees. This needs the answer to be out of quadrant 2. So the answer that would come out of quadrant 2 would be the mirror image of 30 degrees. If you do 180 minus 30, you get 150. So arc cosine of this value is actually 150 degrees. Once again, coming out of quadrant 2, I'll go back 2 slides. If I do a cosine inverse of something negative, I'm getting a quadrant 2 answer. The way I got that quadrant 2 answer is sort of to do the reference angle. So if you know our cosine of the positive version was 30, then you'll know in quadrant 2 it's 150. You do 180 minus that 30. Just to do a couple tan ones, because there are tangent values we know. Tan works the same way as sine. So tan inverse of 1 comes out as 45 degrees if you know your table. So tan inverse of 1 is 45 degrees. And I haven't been showing the calculator because these are all numbers we're supposed to know. I'll show it though. If I do tan inverse of 45, or sorry, not 45, tan inverse of 1, I should get 45 degrees. So I will show that. Here's the calculator. Tan inverse of, it's not really clearing it up, but try to make it so you can read it at least a little bit. Tan inverse of 1, see it's 45. Now if it asks me tan inverse of negative 1, it's going to give me the answer in quadrant 4, and it's going to do like sine does, it's going to give me a negative angle. So basically, going back to my table, if I do tangent inverse of something negative, it's going to give me the negative quadrant answer. I'll show that in the calculator as well. So there's tan inverse of negative 1, and notice it gives me negative 45. All right, so the answers to these, this was 150 degrees. This was 45 degrees, and then this is negative 45 degrees. So the positive ones aren't that difficult. The positive ones are whatever would come out of your table. The negative ones are a little tricky because for sine and tangent, negative ratios give you angles in quadrant 4, which are negative angles. And then if it's cosine, they give you angles in quadrant 2, which come out as positive angles. So try to get that straight. Maybe you need to listen to the video a few times to get that. Hopefully you get it this time. It's a little difficult, but there'll be a sheet that has some problems. You could try them, and I'll probably make a video showing the answers to them. But unfortunately, we need this going forward because if we're going to solve trig equations, at the end of the trig equations, we're going to use trig inverse. One last thing, and then this is done. If they ask an inverse that's not one of your table values, well, then you're able to use a calculator to get it. So if it's not a table value, like 1/2, radical 2 over 2, radical 3 over 2, and those kinds of things, you just use a calculator. Now, you won't get an exact answer, but it is what it is. So since this is asking me what angle, now this is positive, so this is going to come out of quadrant 1. It's asking me what quadrant 1 angle, where when I take its cosine, do I get 5/12? Now, that's not one of the ones we memorized. We don't know what angle that is. I'm going to throw it in the calculator to get an estimate of the answer. So cosine inverse of 5 over 12, and the inverse, you can just hit, it's hard to show this on the camera, but you just hit second in the sine, cosine, or tangent to do the inverses. So I have cosine inverse of 5/12. Remember, this is going to give me a quadrant 1 angle that if I took its cosine, I would get 5/12. Now, most of these, if you put in a nice number, you get out a gross angle. So what angle has a cosine of 5/12? The angle is 65.37568165 degrees. Once again, that's an estimate because the decimals keep going. The calculator doesn't show you all of them. So that's why we prefer the exact answer when possible. The ones I showed you before have exact answers because we know them out of our table if we have our table memorized. If it's not a table value, you have no choice but to get an estimate in the calculator. So anything that's not from your table, just go and get the calculator estimate. When we do trig equations, sometimes it'll be a table value we get, and we'll know it exactly. It won't be uncommon to get values that aren't in our table, and we'll have no choice but to estimate them. So in the case of the 5/12, I have no choice but to estimate it around 65.38 degrees roughly. Okay. Hopefully it's made some kind of sense. Like I said, this is kind of a difficult thing for some people to get their head around, but I'll give some problems a try out, and if people are interested, like I said, I'll probably make something that shows the answers, and the more you do it, the more you get it. All right, that will end this video. The next one will most likely start showing the process of using this to solve trig equations.